Hi there. It looks like this is the question that you're asking, specifically about finding, drawing the area. So the hardest part about these types of integrals, finding the area of these regions, is like actually drawing the region itself. So to take a really generic problem, to find the area of this region below, you're going to have to take into account, like an integral is the area under a curve, but in this case we only want the shaded area. So that's below f of x and above g of x, and then within those limits of integration a to b. And so we're going to set that integral up just like this. So for the first question, we're given the curves or the lines y equals 4 minus x squared and the x-axis. So x-axis is pretty easy, and then 4 minus x squared, there's a little negative in front of the x squared, so it's going to be a downward facing parabola, and there's a 4 there, so the vertex is going to be shifted 4 units up. And I'll go over that a little bit later. But this is the shaded region we're looking for. And if we stick this into that integral format I showed you earlier, f of x is going to be that parabola, and then g of x in this case is going to be the x-axis, so it's just going to be 0. And then the limits of integration are going to be -2 and 2, because we want to go from left to right, and there's no shaded region over here. So -2 to 2, we're going to stick that 4 minus x squared minus 0 in there, the dx, and then we solve it like this. Pause it if you'd like to look at that calculation. So for the second question, this one is a little more difficult. So y equals x squared minus 2x plus 3 is going to be the first curve that we're going to pay attention to. In order to graph this without a graphing calculator, we need to put it into the form y equals, there's going to be plus or minus, and then x minus a, when a is some number like 1 or 5. And then close the parenthesis and square, and then plus b, again, another number like 2 or like 5 or something. And so if it's a positive here, then that parabola is going to be shaped like a smiley face. If it's a negative, it's going to be shaped like a sad frowny face. And then the numbers a and b, that's where the vertex of the parabola is going to be. So if you look at this parabola down here, the vertex is that point right there. And that's going to be the point at the point a comma b. So this is currently not in this form, so we need to do that. And to do that, we're going to have to do something called complete the square, which a lot of people hate and some people love. So we want this x squared minus 2x that I've put in parentheses here to look something like an x minus 1 or x minus 4 squared. And to do that, we're going to add 0 in a really fancy way. So we can add 1 inside the parenthesis and then subtract 1 outside the parenthesis. So we're technically adding 0. We're not changing the function. But we can take the stuff that's inside these parentheses now, and that is now x minus 1 squared. And then minus 1 plus 3 is just plus 2. Now this is in standard form. A is 1, B is 2. Our vertex is going to be at the point 1 comma 2. There's a positive out here, so the parabola is going to be pointing up. It's a smiley face. And then we can go ahead and draw this parabola right here. And so the other lines we were given were x equals -2 and x equals 1. And so our limits of integration are going to be -2 and 1. And then f of x is going to be this line up here, our parabola, which we are given as x squared minus 2x plus 3. And then we're subtracting from the x-axis. So right there. And then I found you the intersection points here if you like, and then there's that calculation for you. Question number 3. So here is y equals square root of x plus 1, the x-axis, the y-axis, and then x equals 8. So y equals square root of x plus 1. We're going to go ahead and, well, okay, first of all, we're going to notice that this has a domain right now. Anything inside of a square root must be positive. So that means our y value must be greater than 0. We're going to come back to that. For the moment, let's square both sides. So y squared equals x plus 1. And then subtract 1 from both sides, so x equals y squared minus 1. And I'm putting it into this form for a reason. And that reason is because x equals y squared minus 1 can be graphed a lot like y equals x squared minus 1, but flipped. So we just sort of flip these axes. So first it looks like this, and then we change it, we flip it 90 degrees, and now it looks like this. But keep in mind that original square root means our y has to be greater than or equal to 0. So we're going to go ahead and just cut off anything that's y less than 0, because that's not part of the original graph.